Help me now welcome Jim Posner, President of the Bremerton Pilots Association and Vice President of the Washington Pilots Association.
Thank you, Doug. That's great. Well, I was getting a little worried everybody showed up at the last minute here. I thought we were going to have a couple of people here today. But this is a nice turnout, and we'll have both this presentation on video that'll be eventually up on YouTube, and the first one will be up on YouTube as well. So we'll see how that works. We're keeping our fingers crossed that you can hear the audio. Anyway, thank you all for coming. This is terrific. Again, we've got Wings program credit. Just maybe we can circulate a piece of paper. Somebody's got a piece of paper. We can start a circulation. And if anybody wants to sign up for Wings, just give me your name and your email address. That's all they apparently need. They don't need your certificate number. I thought they did last time, but if you have the email address and your email address is associated with the Wings program that you signed up for, then that's all you need. Last time we talked about the theory of icing, sort of as a refresher. Today I want to concentrate on the practical applications of that, flight planning, what the internet tools are. If you saw the slideshow that I sent out to everybody, you'll see that there's some pretty interesting and very, very sophisticated tools available to us now for anticipating icing, forecasting icing, and to kind of see where we need to go to avoid it. So there's some tools, a little bit about what happens in flight when we encounter icing, what kinds of things we can do to get out of it, how to develop a plan B, those kinds of things. And then we'll talk a little bit about some stories and some real world applications of how do we deal with ATC, how do we deal with just what's in that environment, how do we deal with that to stay safe. So that's the program today. Jim, from the last time, is from the Center Weather Service over in Auburn. He's the meteorologist that helps them all understand what's going on in a real-time basis. And then he uses these tools as well to help with that process. But he gave us a very, very nice presentation last time, and I expect we'll see something nice today. Do we have any questions or anything, logistics, or anybody have anything before we get started? All right, Jim, over to you.
Okay, thank you. As you know from last time, for those of you who are here, I'm one of the meteorologists at the Center Weather Service Unit in Auburn. That's the en route air traffic control facility for the Pacific Northwest. And before that, I was in New Orleans working as a forecast meteorologist. So I did marine forecasting, aviation, public forecasting, just a wide range of stuff. And then before that, I was with American Airlines, and I was a meteorologist for them. So for today, as Jim mentioned, I'll do a little bit of a review on what we did last time, and then I will shift over to tools that you can use to help avoid icing. So just as a review for the causes of icing, as a reminder, it's not caused by ice and clouds, but it is caused by supercooled liquid water, and that is water that's below freezing but hasn't actually frozen into ice crystals yet. And when that hits the airfoil, then it will freeze instantly. And the aircraft must be in clouds or some sort of visible moisture or precip for icing to occur. And the combined effects of icing are cumulative, so just a little bit of icing on the wings is one thing, but when you combine that with icing on the propellers and the engine, and that can cause a combined effect that will help to could potentially bring down the aircraft. And just as a reminder, on a standard day, if you go up into the atmosphere, you lose about 2 degrees Celsius per 1,000 feet. So effects for, the icing severity factors, it's based on liquid water content, so the more water you have, the more icing that there could be. The temperature, go into that a little bit more again, but basically you need to be below 0 degrees Celsius, and generally 0 to 20 below is the best for icing, or worse, depending on how you want to look at it. Droplet size is basically the smaller droplets, they'll cause rime icing more likely, and the larger droplets tend to cause clear icing. Cloud type, so these stratus clouds that we see so much here, those tend to be smaller droplet size. But the cumulus clouds associated with thunderstorms have a lot of larger droplets, so you can get more clear icing. And also with the cloud type, as a reminder, the cumulus clouds tend to cover a short, not as wide of a span, so you can get out of them or go around them much more easily. But the widespread stratus clouds can cover pretty much like the entire Puget Sound area, so you may have a hard time getting around them. And then the airfoil geometry, as I mentioned last time, the shape can be a factor. The shorter radius areas tend to build up the ice faster. And airspeed, so simply if you're going through an icing area much more quickly, you might be able to avoid a lot of icing, but if you're going more slowly, it can build up much faster. And then that's also with the duration of exposure. So for supercooled liquid water formation, basically ice formation requires water droplets below freezing and some sort of nucleation point, and it's 0 to negative 40 degrees Celsius. And the nucleation point can be an impurity in the water, it can be other ice crystals. The impurity could be minerals, salt, anything like that. And when the molecules align, this could be due to a jolt, or for example, the water hitting the airfoil, the ice will begin to form. So as an example, this is a bottle of supercooled liquid water, and when he slams it on the surface, you can see the ice just forming from the top down. And so that's basically a good example of ice formation. So when the molecules align, it just needs the right scenario for the molecules to align and then the ice to start to form. And for temperature, as I mentioned, it needs to be below 0, and the water can't exist below 0 degrees Celsius. And the best, or the worst, how you want to look at it, range for icing is 0 to negative 20 degrees Celsius. And generally, as you get closer to 0 degrees Celsius, it tends to be clear icing. As you get closer to 20 degrees below 0 Celsius, that tends to be more rime icing. And then as you go farther up into the atmosphere, as you get above negative 20 degrees Celsius, farther up than that, you start to see more ice crystals and not much liquid water. And ice crystals aren't really the problem for icing because they're already frozen, so if they hit the airframe, they'll most likely just bounce off. So for the types of icing, as I mentioned, we have the 3 types: clear, mixed, and rime. Rime is by far the most prevalent, over 70% of icing reports, and then clear would be the second, that's a little over 20%, and the remaining is mixed. And basically, clear icing is generally between 0 and negative 10 degrees Celsius, and mixed, negative 10 to negative 15, and then rime would be negative 15 to negative 40. So for clear icing, which tends to be the most dangerous, clear icing, it's hard and glossy. It can be transparent, so it's not always easy to see at first. If you're looking out on the airplane, especially if it's at night, you try to look at the wings, you may not even notice there's ice out there just by looking at it, but there could be. And the lower picture is a good example of that. If you're not looking closely, you can miss the fact that there's ice on it. And the other problem is it tends to go farther back on the wings, so it can be beyond the reach of de-icing boots, and also, so therefore, you may be able to get the ice off the front of the wing, but it may still be lingering on the back of the wing and cause more problems as you're flying. And it's also hard, heavy, and tenacious. It can be hard to break up. It's just more like a solid block of ice, so it can be harder to break up and remove from the wing. And as far as the airflow around the wing, the gray area is where the airflow is stagnant. So this is in a no icing scenario. This is what you want to see when you're flying. And then at the bottom, you see where you have clear icing, and it tends to form horns, so it makes the wind flow around it much more turbulent, and therefore you could cause problems with lift. And maintaining your altitude. And it's also, because it can go so far back, it can, as I mentioned, it can be harder to remove with your de-icing equipment. So this is the icing accretion example. So basically, imagine you already have some ice on your wing, and then you take some super cold liquid water if you're in freezing rain or if you're just in a cold air situation. You could basically just imagine the water hitting other ice on your wing and just continuing to build up. This is a pretty good example of what it could look like. So it can accumulate very quickly. You don't want to be in this type of scenario for long. You want to get out of it as quickly as you can. Rime icing is the most prevalent, slightly less of a problem for de-icing equipment. It's opaque. You can see it much better. It has gaps in between the ice crystals, so it's much more visible. So even at night, you might have a better chance of seeing it if there's any light shining on the wing. And it's lighter than clear ice because of those gaps in the ice. It's a little bit lighter, and it tends to just form toward the front of the airfoil, of the wing or the airfoil, and so it has a better chance of being removed by de-icing equipment. But the shape will still cause problems with the aerodynamics, so you'll still have problems maintaining lift with the ice on the wing. And since there are more of the gaps in the ice, it's easier to break up and remove, and it doesn't tend to form as far back on the wing, so as I mentioned, the boots should hopefully be able to remove it. So this example, gray again is where the air is stagnant, and then the white is where you see the rime icing. So when it starts, there is some turbulence in the airflow, but it's not too bad. It tends to form at the leading edge of the airfoil. And again, it's easier for the de-icing equipment to remove. And if you compare it with the clear icing on the bottom, with the very turbulent airflow, that's obviously going to be much worse to try to maintain your altitude. And then mixed icing, that's just a combination of both rime and clear icing. And basically, it's easily seen at first since you have the rime icing in there with the gaps, and it's much more opaque, so you have a better chance of seeing it. And it forms when you have varying size water droplets, and it's intermingled with snow and ice, so you have a better chance to see it. But it has similar hazards to clear icing. It can spread out on the airfoil beyond the reach of the de-icing equipment, so it can cause problems. So again, with mixed icing, you still have the horns forming. It goes farther back on the wing, so you definitely want to get out of this type of situation as quickly as possible. And again, it'll be more difficult to remove with the de-icing equipment. And then pretty much the worst scenario you could be in is freezing rain. And I'll try to go through this as slowly as I can. I know this is a quick slide for this, but basically when you have frontal boundaries, you have warm air overrunning colder air. So the warm front in red, you have warm air coming up from the south, and that when you hit the frontal boundary, it starts to lift and go over the cold air that's farther down. So if you have near freezing temperatures in your vertical profile, as the precipitation comes down, it'll go through warm air and then hit cold air again. And on the cold front side, it's basically you have the cold air pushing in and sinking and going underneath the warm air and pushing the warm air up. So again, you have warm air above cold air. And so in this scenario, the precipitation will begin as snow, and then it changes over to rain during crossing the frontal boundary, going vertically downward toward the surface. And then it becomes super cold liquid water, and it can freeze on impact as soon as it hits something. So again, this is one of those scenarios where you can have heavy icing in a very short period of time. You don't want to be in it for any
The super cool liquid water, can you tell us what that is?
that's water that's below 0 degrees Celsius.
So freezing?
Pardon?
Why is it not freezing?
It basically you have something to cause it to freeze. So if you have pure water, no disturbance or anything, you can get it down to close to 40 degrees below 0 Celsius, and it can still remain liquid water. You need either an impurity, so the molecules can cling to it and align properly to form ice, or you need some sort of like the jolt, which I showed, which could be the water hitting the airfoil, something like that can help align the molecules properly so they'll form ice crystals. And for freezing rain, again, you want to be cognizant of the atmosphere you're in. So the best maneuver may be to go up if you can get into the warm layer, or if you can get around it. Just make sure you know your best escape route whenever you have a chance of getting into freezing rain. So I'll show you the soundings. A couple examples. On the left, that's for freezing rain. On the right is for sleet. So on the left, you have snow falling in this example, and then it melts as the temperature goes above freezing. So the blue line would be the temperature curve, and then the vertical line is 0 degrees Celsius. So as it falls into the layer that's above freezing, it'll start to melt, and in this scenario, it'll fully melt, and it'll stay melted for a while. And then as you get back down closer to the surface, you still have trapped cold air underneath, and it gets cold enough you can get some freezing rain. And the sleet sounding, basically, you start with snow falling from the clouds. It goes into a much shallower warm layer, so it may not fully melt, it'll partially melt. And then it has a deep cold layer below it, so it'll refreeze and turn to sleet. So that's a perfect example of when you get sleet in the area. And again, sleet, since it's already frozen, isn't really a problem for icing, but that area where you have the partially melted snowflakes, if your airplane was already in below freezing temperatures for a while, if you've been flying, it could be cold soaked. So even if, say, you're at 1 degree Celsius air temperature outside, if the skin temperature of your airplane is still a couple degrees below 0, that could still cause icing. So you need to be very careful anytime you're near freezing temperatures. If you've been in below freezing temperatures for a while, it may take a while for your airfoil to rise back above freezing. And an example, as I mentioned, I used to work for American Airlines, and a little bit over a year before I started there was a crash due to icing. So this was back in 1994, and an ATR, if you're familiar with that, it's a turboprop airplane. American Eagle used to fly a lot of them. They still have a lot, but they've moved them all to the south, away from icing situations as much as possible. But it was scheduled to depart from Indianapolis to Chicago. And this was back when I was in grad school, so I very distinctly remember this event happening. And I was at Purdue, so it was pretty close to the route. So it entered a holding pattern at around 10,000 feet going into O'Hare. And the flight data recorder indicated level 3 de-icing was activated during descent to 10,000 feet. And they went into multiple holding patterns, and then a ridge of ice accreted beyond the de-icing boots during the freezing rain or drizzle event in the holding pattern. And they didn't fully understand how bad the scenario was with the icing. So the icing built up beyond the de-icing equipment, and it wasn't able to handle it. They did one roll. The pilots managed to get control, at least briefly, of the airplane again, and then it went into another roll, and then that was it. So basically, it was a combined cumulative effects of clear ice, and this was near Roselawn, Indiana, and this was the remnants of it. Apparently, I believe it went down so fast there was no fire even. It just basically dispersed all the fuel. It just parts everywhere. So this is an example of what we don't want anyone ever to experience again. We definitely want you to avoid clear icing and also any other icing situation, but be very cognizant. Icing can cause problems quickly, and you want to get out of it as quickly as possible. And as a result of that, American Eagle basically moved all their ATR aircraft, tried to get them down into the hubs in San Juan and Miami, so they could avoid almost all icing situations. Okay, so getting into situational awareness, you want to keep current with what's going on in your area. So this is an example of icing air mets. And then know where your fronts are located. As I mentioned, you have the overrunning of warm air over cold air that can lead to freezing rain, freezing drizzle situations. Keep current with the freezing levels in your area, and that's one of the websites you can look at to keep abreast of that. And there we go. So know the cloud bases, know the cloud tops. Most light non-turbo aircraft can't climb above 8,000 feet, and if you need to get up there, can you stay there? And are the clouds air mass or frontal? So as I kind of glossed over before, I went through a little bit more in the last presentation. If you have the widespread stratus clouds, for example, covering the Puget Sound area, if there's icing in that situation, it may be very difficult to get around it. There may be no place to go without maybe going down even toward Portland. But if it's air mass cumulative clouds associated with thunderstorms or very scattered showers, those you have a better chance of being able to get around. And also, are alternative routes available? Can you get around the fronts? Can you get around the mountains? So for current and forecast icing potential, you can go to the Aviation Weather Center website, and I'm going to show some slides here, and then periodically I'm going to go onto the internet and we can look at current data, but this is just, so it's a reference and slides I captured along the way. So on the left, it's this was from, I believe earlier this month, 22nd of February. So it's a map of maximum icing severity, and basically it shows icing from Southern California through Texas and then going up a little bit into the East Coast. And that's from 3,000 to 30,000 feet. And then the red hashed areas, that's the super cold liquid water danger, or drops, I'm sorry. And then you can also do a forecast. So it goes out 18 hours, and you can do different levels. You can go 010 to flight level 290, and you can go 0 to 18 hours out, and you can see the different forecasts. This one was the icing severity at 13,000 feet at, I believe it was 12 hours out. So basically, things you should know in most freezing rain episodes: a climb to warmer air aloft is in order. Heavy accumulation of ice can occur in cumulus clouds. Get out of them as quickly as possible into VFR conditions immediately. So even though cumulus clouds don't cover as much of an area, you can get very severe icing very quickly. And stratiform clouds, you want to change your altitude to a level that's above freezing, or an altitude that's colder than -10 degrees Celsius. Try to get higher where there's less liquid water and more ice crystals. And it's best to just get out of the icing as soon as you first detect it. So, for the web stuff, this is homepage for where I work, the Seattle CWSU, and the website is up here. And just so you know, I updated the presentation yesterday. There's one slide at the end which basically has a list of all the websites. So if you look at the presentation, you can get one web page that has all the websites I reference here. But again, the web page here, this is our home page. So you can see the map. The thicker line shows the Pacific Northwest, the Seattle ARTCC, and the area we're in is the northwest part. And the colors: green would be VFR, blue is marginal VFR, red is IFR, and the pinkish purple is low IFR conditions. And if you go onto that website, if you click the layers button in the upper right, you can change the parameters that are on there. So you can display, I switched it so it shows on the right side icing air mets and pyrups. So you can see the pyrups plotted and icing air mets. May not be too great here, but I'm going to open a slide so we can do this interactively. And we also have icing forecasts. So if you go up to the forecast menu item at the top and then go down to icing, we have a page that shows different icing products. Right here, it's the highest freezing level. That's in the Pacific Northwest. So we'll go to current data. Of course, whoops. Oh. Not connected. Let's see. Okay, the Wi-Fi turned off. Hopefully it still remembers the connection. Let's see. So, okay, so which one do I use?
One says, I think it says guest.
Oh, guess, okay. I'm surprised I didn't remember that from last time. There we go. Sorry about that.
Very good.
Yeah, it looks like it. There we go. There it goes. So here is the web page I mentioned.
Excuse me, Jim, for a second.
Yes.
Does everybody who wants to sign up for the wings page? Okay, this is the list of wings. Thanks.
And let me know whenever you think is a good time for.
That's right.
Yeah. So, okay, so this is the homepage for our website, and unfortunately, for this demonstration, there isn't a lot going on. It's VFR until you get all the way down towards southern Oregon into northern California. But you can see down in the southern part, the blue, that's the marginal VFR, and then you have a couple, in the mountains, you have a couple terminals there, low IFR. But you can move this map around, but I guess as an example, if you hover over the different terminals, you can get the height, the elevation, you can get the current observation, and if it's a TAF site, for example, Port Angeles, it will also give you the TAF, and it gives you sunrise, sunset, and civil twilight calculations, and other links to data you can click on, but you can get that very quickly here. And if you're on a phone, this also works. As you see toward the top, you can do click or hover, and it will try to default to click if you're on a phone, so you'll have to tap. And if you want to move to a different area, Oakland should have, so ZOA, that's the Oakland airspace. Probably should have just moved the map, but anyway, so take a sec, should plot the terminals, hopefully get a little bit more interesting weather for this demonstration. So you do have more IFR conditions. And what we can do is zoom out a little bit and turn off the flight category, and I'll show the icing. So on the right side, that's the icing AirMets, SIGMETs, and CWAs. The CWAs are center weather advisories. If you're not familiar with them, that's what my office issues. And that's more of a very short-term forecast or warning advisory for what's going on. And it may be just a precursor to a SIGMET coming out. So we can add the icing AirMets, so you can see icing all the way across pretty much the southern tier of states. And add some high reps, so that's on the left side. And for the PIREPs, if you're interested, there's a little change here. You can change how many hours back to plot PIREPs. By default, it does 2 hours. So if you click over here, so if you hover over hover over this, you can see the icing AirMet. So it's basically between 4,000 and 12,000 feet, and it says the conditions are expected to continue beyond 21Z through 3Z. So it's expected to continue through the afternoon into the evening hours. And this is, icing AirMets display anything moderate icing or greater is expected. So especially in smaller aircraft, and if you don't have de-icing equipment, you don't even want light icing. So that's something to keep in mind. Even though this AirMet is out, it's for moderate or greater. It won't cover light icing scenarios. If we zoom back in a little bit, use that. Maybe a little hard to see, but we have the icing PIREPs. So this is an example of mixed icing where you have the regular U and the upside down U. So light mixed icing, and it's at 120, and that's definitely within the area. So the range in this area is freezing level to 18,000 feet. So then go back to the CSE page. So it's a similar format for the 4 Western Region ARTC's home pages. So the other thing I showed was the forecasts. So we have icing. If you go under forecast, you go down to icing. And this isn't everything that's available out there. We'll get to that in a minute, but just as a quick review. So just a bunch of links on the top. So for the analysis, that's what shows up initially. This is icing severity, similar to what I was showing before. You can see the icing stretching from Northern California through Texas. They had a pretty good ice storm, or snowstorm. Well, for them, they had some snow. I believe it was yesterday that was shutting down the roads and everything. This is icing severity. This is the maximum from 1,000 to 30,000 feet. And as you go, it goes from none to trace, light, moderate, heavy. And then the super cold liquid droplet threat, that's the hatched area in red. And they also have some PIREPs plotted on there. Then you can go out 3, 6, 9, 12-hour forecasts. So I can just do an example, do the 6-hour forecast. So it's a similar format. You're not going to see any PIREPs on it. But as you can see, it's expanding over the western U.S., California, Nevada, Utah, Arizona. Some of this is associated with the upper low that's dropping into that area. So you're going to get more shower activity, more potential for the convection and the clear icing potential as you get clouds building vertically. And then you get the super cold liquid threat, drop threat as you go from Texas into Illinois. And then up at the top, you can go 3 through 12 hours out. Freezing level forecast, so this should be a current one. We only send up the balloons twice a day, 0Z and 12Z. So this is something based on model data, so you can get something more current. So this is just for the Pacific Northwest, various terminals in the area. So this is the highest freezing level. So once you get above this, you keep just going down as long as you're in the atmosphere. And then as you go farther down, it doesn't cover if you have multiple freezing levels. But in the Pacific Northwest, so right now, Seattle area, it looks like it's around 4,000 feet for the highest freezing level. It gets lower as you get toward eastern Washington, and then it's at the surface when you get into Montana. And then the final, you can do a forecast one that goes out 12 hours, similar situation. So, give it a sec. And the freezing levels are starting to go up, so it gets up above 5,000 feet in our area, and this would be for 5Z this evening. And then the last link brings you to the Aviation Weather Center homepage, which I'll go through this more in detail in a little bit, but this takes you directly to their icing page. Okay. So any questions on that before we go any farther? Yes?
I just want to be clear on that. Now, highest freezing level, why isn't it lowest freezing level, or is there another chart that shows lowest freezing
There
level?
are other charts. One of the things that the Aviation Weather Center will show lowest freezing level. For the group in the RC where I work, that's what they want to see. They want to see the highest freezing level. They want to know once you hit that, it's just below freezing above that. So that was their request.
Okay.
So, but some of the data we have, you'll be able to see the multiple freezing levels. You can see the lowest. So that's not the only way. That's not the only source of information.
I'm still not clear what that highest freezing level means. That means when you get to that altitude, you're going to encounter freezing temperatures.
Yeah, once you hit that and you go above it, it should stay below freezing.
Well, that would seem to be the lowest freezing level.
Well, you
to
could
be
have,
that high.
you could, basically if you go up in the atmosphere, so you can start off, say you're at a few degrees above freezing, it drops below freezing at 5,000 feet, then by 10,000 feet you go back up above freezing, and then 15,000 feet you can go back below freezing. So 15,000 feet would be the lowest freezing, or I'm sorry, the highest freezing level then. So highest above the ground.
Okay.
And a couple other pages from my office. We have a mobile web page which has links to things that could be of interest to pilots. It's geared more toward a mobile app, a mobile phone or a tablet, so it'll look a little bit better. And then I created this swipe page since didn't really see much in the Weather Service yet. That's kind of geared more toward iPhones and Android phones. It's a swipe page, and I can't really show that here, but you have the link, and I'll do the best I can to try to show it. So going to the mobile webpage. So this is a bunch of links that are available. We have the radar at the top, so you can see an image. So for the Seattle radar, you can get the radar image right there. That one is not looping. You can get a looping image also. Take a little bit, but there's obviously not much going on out there, as you can see looking out the window. And then satellite, we have IR, which is the infrared that you can use 24 hours a day. The visible, we'll do a west one since there isn't much close to us, but this is a larger west image so you can see everything, the western part of the US out into the Pacific. You can get observations, TAFs. So I have Seattle and Portland just linked already. So if you want to get that, this is from the Aviation Digital Data Service, and they'll give you the current observation and TAF. So right now, clear, 10-mile visibility, no clouds expected through 0Z tomorrow. And then if you want to do something else, so you can do KWT. So we don't have a TAF out here, but you can get the current observation for Bremerton. And looks like winds are out of the north, 10 gusting to 20. Go farther down, you can do Pacific Northwest PIREPS. So you can see the PIREPS. So first image is icing. So the only report is of no icing, that's in Western Oregon. You go farther down, reports of turbulence. So that's a little, today that's actually more of an issue. You have some high-level turbulence that you get into Oregon, and also some lighter turbulence. You go farther down, this is just wind and sky reports. And then farther down you can get the actual text of the PIREPS. And let's see, if you want forecast discussions, you can go to see the discussions and maps. This is actually from the Oakland webpage, Oakland CWSU webpage. I'll show you a little bit more about that later. But you can look at that, you can do the forecast. Oops. So showing the frontal system developing in Colorado. That should be kicking out to the Midwest later today, or later this week. And then as you get farther down, various images, we analyzed a jet stream image. So this is from this morning, showing the jet stream coming in out of Canada and off the British Columbia coast, kind of merging and then going back across the southern tier of states. And for the swipe page, which I don't know how many people know about it, but I've tried to mention it to various people. So when you first call it up, this is basically our homepage /swipe.php. It'll come up with this. You'll have the gray box kind of describing what you can do. If you swipe left and right, it goes through the different panels. If you swipe up, that'll turn the header and footer on and off. And if you swipe down, it should refresh. And in the upper left corner, this defaults to, looks like Boeing Field right now, so you have the observation for Boeing Field. The upper left is temperature, lower left is dew point, visibility is in the middle on the left, upper right. How old is that? Showing 2,200 feet. Oh no, I'm sorry. Sorry, that's the mean sea level pressure. The ceiling would be on the lower right. So if you click on this, that'll disappear. And then if you do the swipe left and right, you can get the different graphics. But the opening one is radar, so you can select different radar sites. You should have 3 local ones. So Seattle, over at the coast, and the Portland radar. You can also do the regional radar. Calls up. There you go. They're all looping radars. And then in case you can't really swipe, I do have the arrows in the top, so you can go through the different panels. So if you could swipe over to the right, you get satellite images. So on the left is visible, on the right is infrared. As you can see, Washington is pretty clear. You don't get clouds until you get down toward Oregon. Swipe again, and this is Boeing Field, so you get the TAF and then the local observations. You can change different TAF sites, so if you want to go up to Everett. Again, it's pretty boring today as far as TAFs go. And then you can get the local forecast if you swipe again. So it goes out for 4 periods along with the current period, so it goes through Sunday night. No rain expected until Sunday, so it's just the general public forecast most people are used to. If you want the aviation discussion, if any of you have looked at the discussion section of the aviation section of the discussions that we issue at the forecast offices of Seattle, Portland, Spokane, Medford, they all issue an aviation-specific discussion so people can see what's going on. And again, it's going to be a little boring, but this is from the Seattle office. Large upper level ridge centered over the Northeast Pacific will maintain dry northerly flow over Western Washington through Sunday. And then it just describes what's relevant to aviation. And if you want the Aviation Weather Center area forecast, if you click on this, it'll open a new window. You can select the different area forecasts. So we have one that's geared toward the West Coast, Salt Lake City. Click on that. You can get the area forecast discussions. I don't know if you're familiar with that, but that's one of the options out there.
Question,
Yes.
the radar images that you just showed, that's real time?
Yes, it should be. There should be a timestamp on it. So I'll go back to the radar. Also at the bottom, you can click on it. So in the lower down here, it has the image. So it looks like the last one of the loop is 1728 Z. Yeah, it's always good to check the timestamp just in case something is old. But the composite images should always update. If an individual radar site is out, you'll get it'll just be black and it'll say no image due to being serviced or something. I don't remember what the exact terminology, but it'll be a black screen, so you shouldn't be confused by it. Yes.
Well, a lot of times on the do-outs report, it says for the Puget Sound Interior Valley, it says clouds layered to 20,000. That seems to be the standard. But you get out and it's like tops are 5,000. Beyond PIREPS, is there any other service where you can find cloud tops beyond that like general forecast?
Well, you can look at the PIREPS. You can look at the TAFs. The only thing is with TAFs, if you have a lot of layers, we can't, once you get above a couple layers, you can't really write a TAF above that. So.
What is QT?
Yeah, and we're going to get into the SKUTs. So yeah, if you want forecast, you can look at that and get an idea of the moisture at different levels and where you're likely to have clouds. So that's one of the things we're going to get to, like 2 or 3 things.
So on your web page, you got, so Boeing Field is at the top.
Yes.
Can we change that to, or is that?
Yes, yeah, that'll be one of the panels later. So you can change it to whatever terminal you want. You can pick it on a map. So, and then you can set different cookies so it'll remember different locations, so you can just quickly go to that. So for this is the, sorry. Yes?
On this page here with the 3 numbers to the left of each airport, there's a red, a yellow, and green. What do those stand for?
The red is temperature, the yellow is visibility, the green is dew point.
Perfect.
And if you click
I
on
see
the
wind
help,
is there too.
yes, again, if you click the help on the lower right, that'll open that gray panel again, and there's a diagram of the station model plot. It tells you what each thing is.
This is really great.
You're welcome. So this is the well, on the upper left is turbulence, on the upper right is icing. Lower left is IFR and mountain obscuration, and then the lower right is thunderstorm or convective activity, so you can see the 4 maps. And and again, one thing I hadn't been mentioning, if you click the zoom out button, it'll do an expansion of just the data that's on that page. It may bring you to a new page with more extensive information than what's just available here. And then this is a station model plot of the local area, so similar to what's in the upper left. So basically this is centered around Boeing Field, and you can see, if there were ceilings, you'd see it in a cyan color, light blue in the lower right corner of the station plot, but again, no clouds out there today. And again, if you click on that, it'll expand it and you can move the map. And it's very similar to the map that I showed you at the front of our homepage. This is a vertical wind profile. So this could be useful on a day like today. We do have some stronger winds as you get aloft. So basically, as you go from 0 to 20,000 feet, you can see the winds. The left is 17Z, and it's a forecast out in time. That red line is the highest freezing level again, so you have a reference at least for the highest freezing level. And you can see mainly north-northeasterly winds getting up above 50 knots as you get near 16 to 20,000 feet at some points. And then we have model data. I'm not sure how many of you are used to looking at this stuff, but these are some of the models that we check. So this is again for Boeing field going out. Z time on the top line, you can see forecast, and this is just model data, so humans haven't touched it. So you can see temperature forecast, dew point, so on and so forth. And you can go through the different types. So if you want a long-range forecast, that's the GFSX. You can see forecast going out, and that goes out to Sunday. But again, this is all model data, so I haven't done anything to that data. Okay, so this is where you were asking, you can change the airport locations. This is the last panel. And if you just want to type something in, you can type in Bremerton, and click Use ID, or Enter. There we go. So it just reloaded the page, and just so you know, this gray, after like 10 times or so of loading it, it shouldn't keep loading it, but now you're at Bremerton. And if you want, when you go back to that page, you can save this configuration. So if you want to save Bremerton, you can have 5 locations. You can save it in, say, the first location, and what do you want to call it? You can call it PWT, or you can call it Bremerton. And then if you reload the page, so if you, assuming say you're down in San Francisco, if you want to see what's happening in Bremerton, you can just click that. The other way you can do it, if you open the map, you can just move it around, and that little National Weather Service icon in the middle will be where the page will be centered after that. So you can try to just drag it somewhere interesting. So get down, go toward Red Bluff, and just click Use Map. And then it'll refresh the page and find data that's relevant to that area. So there's radar down there. We'll get the local forecasts, local satellite, give it a sec to load, but we can go through that. So hopefully this will be useful. I'd love to see more people use it. Yes?
Does your website satisfy the requirement to give a flight briefing before we flight?
It does I don't know if it, I think you can get the full briefing there, but I'm not sure it covers every single item.
But you don't ask for our tail number, so is there a record of it?
Oh, no. This was just a personal briefing. You can look at it and find all the information.
But it doesn't satisfy?
If you have to record something, it wouldn't satisfy that. Okay. And any other questions on this?
That's all part of the mobile app.
Yeah, that's the mobile. And then next. So the Oakland CWSU, they also have, more people are familiar with this website. This is their mobile web page. So you have aviation text, hazards, radar, satellite, discussions, and maps, which I briefly showed earlier. And wind graphics. So just quickly go through this. This would obviously look better on a device for which it's designed. But for example, you can do the radar. It has the radar, main radar, and then you can click on the local radars. Go back and forth. And you can also get the observations and TAFs. You can search for PIREPs in an area. So, do KSFO. PIREPs, there should be some more interesting ones down there. See Icing Light Rime near Reno, Light Rime near Sacramento, I think that's the Sacramento airport. So, oops. Here. So again, that's That's the website for the Oakland CWSU page, and you should be able to access that from both the Seattle CWSU or the Oakland CWSU website. It should be one of the listed ones under, let's see, go back to our home page. So CWSU Mobile, so that will be the Oakland CWSU page. Oops. Oh, sorry, out of the presentation. There we go. And there's also Weather Service mobile weather. So this, you can just type in the forecast, the location, it could be a zip code, whatever you want, and you get the public forecast. I'm sure you've seen some version of this in the past. This one's just better designed for mobile information and, or a mobile device. And you can also save, like similar to my website, you can do cookies and you can save locations so you can get right back to where you want. Okay, so now this is the model data, the SKUTs, soundings, so you can see the moisture at various levels. So again, this is one, I'll show a couple examples in slides and then we'll go live to a website and try to find a place that's interesting. So website's ruc.noaa.gov/soundings. RUC is actually the old name of the model. It's called the RAP now, but they didn't want to change the website. So basically what you can do is you go to the website, you can select the location, and it'll plot the sounding. So you select the location in this upper area here, plot the sounding, or you can create a bookmark. And you type in the airport, it'll create a page that you can bookmark and go back to later, and that should always take you back to the latest sounding. So on the right, you have the sounding. The red would be temperature. The blue is dew point. The altitude and wind speed are on the right, so that's the light blue is the altitude, the wind is in red. And then at the bottom, where the temperature and dew point are close together or right on top of each other, that's where you're likely to either have clouds or be in rain or some sort of precipitation. You can also change the forecast time near the bottom. And so the other thing to remember with this, if you're not familiar with SKUTs, it can be a little confusing at first. You basically, as you go up in the atmosphere, that's, up is vertical. And then left to right is temperature, but it's skewed. That's why it's SKUT log P. So the lines, let's see if I can do this. The red lines that go from the lower left to the upper right, those are lines of constant temperature as you go up in the atmosphere. And it's based on pressure, so it's as you go up in the atmosphere for pressure. So basically, as I noted here, this was at Hoquiam earlier in the week, I believe. And it was basically the temperature dew point spread was near zero, so you had clouds forming, so the visibility was going down to 2 to 3 miles, and ceilings around 1,500 feet were developing. So here's an example a little bit more interesting. This was from earlier in the week. So this is out along the Carolina, Virginia coast. We had icing SIGMET, so that's moderate, I'm sorry, that could be severe icing near the Carolina coast going out into the ocean. So it was from 120 to flight level 180. And so take that, Wilmington is basically right in the heart of the icing SIGMET. I plugged that into the bottom area where you can pick a location that you can bookmark. As you can see here, again, red is temperature, blue is the dew point, altitude and wind speed on the right, so very strong winds out of the west across the area. And then tried to kind of highlight where the 0 degree isotherm or line of constant temperature is. So basically cuts right through the sounding where it's saturated in the, let's see, basically below 15,000 feet. In that area, the 0 degree isotherm goes right through that, so you're right near freezing in that area. So if you want the observation at Wilmington, North Carolina, you can see 5 statute miles, freezing rain, fog, 900 overcast. Basically the temperature was 2 degrees below Celsius. And so you had, and if you look in the remarks, I'm not sure how familiar you are with reading that, but Unknown precipitation began, which is basically when the device can't figure out what it is. It's normally some form of winter precip. And freezing rain began, ended, so it definitely was ugly there at this time.
Jim, does that show, or do you have any indication of what the tops of those clouds are?
The tops here, it would likely somewhere, probably somewhere.
That's what I want to point out.
Yeah,
is that-
so probably somewhere above, the observation, we don't have the official observation, but if you get somewhere above, it looks like above 20,000 feet, it starts opening up. So you get above 6 degrees, when the spread gets above 6 degrees Celsius change between the temperature and dew point, then it's less likely you're going to have
So go back to the Oakwood one.
Yes. There we go.
And that would suggest that there's low clouds on the ground, right? That they're gonna be very, very low tops.
Yes, very shallow. I think these were just developing, so I'm pretty sure it was like right around 1,500 feet, which is where the, close to the top of that was, you just get a little bit above that.
So everything above that's gonna be clear until you get back up to the altitude where they converge again, so there might be a layer up there.
There might be, but I'm not sure that's close. I don't know if that's going to be within 6 degrees, but if it is, that's as you get.
But if they were to converge, for instance, I would tell you
Yeah,
where
that-
the layer might be.
Yeah. Yeah, they can either be very close
Really,
or.
really useful
Yeah.
tool, this QT thing. It sounds kind of technical, but when you look at it, that's exactly what's going on. So you can see your temperature and dew point spreads
Right.
at the different altitudes. As a matter of fact, when you get onto this, I think you still do it, is that it's interactive. When you mouse up to it, you'll look at, it'll tell you what the altitude is and what the temperatures are at that altitude. And you move it up and down and it changes. So it's just, you can right over the top of that.
Let's see.
See, I have a question.
Yes.
What are the yellow lines that curve this way? Like you told me about?
From the yellow lines, that's from kind of the right, curving a little bit to the left.
Yeah.
So that's the saturation, or moist adiabatic lapse rate. That's something we use in meteorology. It helps us determine if the atmosphere is stable or unstable, and we use it a lot for convection. So I wasn't really going to go into that too much today, but it's one of those tools we use it's more for thunderstorm forecasting.
The same thing with the blue line that curves the other way, it's not that important either?
Well, I don't want to say it's not important, but
Well,
for
for
this
us, yeah.
application,
Right.
it's not what we're
Okay.
on what we're focusing. And then the blue line, that's the dry adiabatic lapse rate.
Oh,
So it's just the two different lapse rates. So
Thank you.
if it's a dry atmosphere, the temperature is likely to follow the dry adiabatic lapse rate, but that's like perfectly dry. And then the moist adiabatic lapse rate is if it's fully saturated, that would be the standard lapse rate for the parcel then. Yes?
Do you have any tricks about how to make the functionality that requires Java that Jim was talking about work on a mobile device?
No, unfortunately, it's a Java application, and I know I know they're trying to get away from that. I suspect that at some point down the road, they'll rewrite the application so it'll use HTML5, and then it'll be fine, but for right now, it's just Java. And these, you don't need Java. This part, you don't need Java. So this should work okay. Okay, so basically I've been showing you for the soundings, just panels I compiled before, so we can try to do a live demonstration here. Hopefully they'll come up a little bit bigger and then be easier to see. So I guess one thing we should see, icing was down. We can try like Reno. I think there was some around there. So if you go to the lower section, this is where you can bookmark an icing. Or bookmark a sounding area. So go to Reno. Okay, so again, you can see it's higher elevation, that's why it doesn't go as far down. So I believe, looks like their lowest elevation, it's a little above 5,000 feet, probably closer to 5,500 feet. But you can see it's saturated all the way, so at the bottom it's a little above 5,000 feet. It's pretty well saturated until you get maybe 15,000 feet, and that's clouds there.
So why don't we have a temperature below 5,000?
It's the elevation of the
Oh,
airport.
okay.
Reno's pretty high up.
Okay,
So let's see, go back to the home page, see if I can find something that's more like Stratus oriented.
Do something close to Portland today.
I think we have to go south, so from what I remember it was southern Oregon.
What's the code for Reno?
RNO.
RNO.
So it looks like, yeah, Medford looks like they might have some. So right now, Medford, according to this, go to Medford. So as you can see here, Medford is 2,200 broken, light winds, and it looks like they may have another layer, about 8,000 feet according to the observation. So you can go to Medford. That's MFR. Okay, so here's a good example. So this is, looks like the moisture, it's maxes out, looks like it's around 3,000 feet. And then I mentioned another one, possibly around 8,000 feet. It's hard to see on this one, but definitely the thick layer is down here. As you get to around 3,000 feet.
And if we're trying to guess the cloud tops, you said you should look for about 6 degrees difference?
Yeah, it's,
Plus or minus.
and that's also, and that's just pretty much cloud, so it's not necessarily going to be a ceiling. So that, you know, if you get down toward like 1 or 2 degrees difference, that's more likely to either be a ceiling or you're in preset. And let's see, try to find another, I think if we go, try DFW. So they're having freezing rain right now, so I'm sure it's a lovely day there.
Yeah.
Freezing rain.
Yes, and so we can check that sounding out. So this is an example where it's overcast, you know, just like 1,100 feet, so we don't have reports above that. You get an idea of what the sounding is. So it's KDFW. Okay, so here you can see it's saturated, basically from the surface, and then the 0 degrees isotherm is right here. So you can see basically going up to the right. Oops, of course I moved the mouse. So basically this right here is 0 degrees Celsius. So you have the pretty good deep cold layer below freezing from about 3,000 or 4,000 feet down. Above that till about 7,000 feet, you're warmer than freezing, and then it drops below freezing again. And so the precip starts somewhere, maybe starting as snow, maybe starting as rain, and then it definitely encounters a very deep, cold layer. So that's where you're getting the freezing rain over the Dallas-Fort Worth area. So that's not a place, I suspect the airport operations at DFW and American Airlines are pretty bad today. Let's see, any other good any other locations anyone wants to try? Let's see.
Can you do this for every airport, or is it just?
US-based airports. So unfortunately, there may be a few internationals you can do, but it wouldn't be much. You might be able to do like Vancouver or Toronto. Let me check. I don't remember if
I just meant, I mean, you don't require reporting on the field for this? You can just.
No, this is all model data. So,
Okay.
and you can actually, it doesn't even have to be above an airport. If you have the latitude and longitude, you can just enter that. So if you're like halfway, you want to see something halfway between airports, if you know the lat long, you can just punch that in and get it there.
How often is that issued? Is it hourly?
It updates every hour, so, and it goes out, I believe this one, the main operational one goes out 18 hours. So there's another backup one that goes out 24 hours, but we normally just use the operational one, so that goes out 18 hours.
The raw data that they use for the model, is that balloon sounding?
It's a compilation, so for the models, they use the soundings, that's the 0 and 12Z launches every day. They also use aircraft reports, so I know Delta, pretty much all their fleet now, and I think many of the planes in the other ones, they'll report temperature, wind, and moisture back to National Weather Service, and then we can put it into our model data. And let's see, that we also put in satellite information, radar, so there are a lot of components that go into modeling data. So let's try one more, see if there's anything. San Francisco. Okay, San Francisco, one more. So let's try to, so San Francisco. You can see down here, looks like it's pretty well saturated most of the way until you get up to somewhere in the 7,000 or 8,000 foot area. Definitely, it looks like they probably have an overcast layer somewhere in the 2,000 foot range. Let's see. See how well I did there with that one. Okay, San Francisco. Oh, that's San Jose. Well, looks like they have scattered clouds, potential broken ceiling right around 2,500 feet. So they do have clouds there. It may not be the ceiling, but they definitely have clouds in that range.
So Jim, on that, scroll it down a little bit.
Like this?
No, the other way,
Okay.
or up maybe.
Yeah.
That's pretty interesting up at the other flight levels where it goes way out and then jags back real quickly. What causes that?
You just have moisture pushing in, so it's most likely we have, you can see over on the right, the jet stream. I think they have some, the jet streams comes in not too far from San Francisco, so that's where you see the stronger winds getting up to 60 knots or so out of the west. And there's moisture. They have some clouds in the jet stream, so that's helping to bring some moisture in, so that's where you're getting.
Just pretty radical
Yeah,
divergence and then convergence again.
yes.
So you're likely to see some cloud layers at what altitude is that?
Yeah, this looks like around 20,000
Around
feet. You
20.
may, it's some moisture, it's probably, as you get higher up, it doesn't take quite as much of a dew point spread, a small dew point spread to be able to get some clouds. There could be some, it would just be cirrus and it'd probably be thin scattered. So let's see, are they reporting anything?
Is there a layer at 20,000?
Oops, a little farther up. So it looks like the report was just 2,400 feet, but yeah, there may be some in the area. If we look at, we can also overlay satellite on here, so some satellite. Visible. So this is the visible satellite in the area. So it looks like not too much going on. A little bit maybe further to the east. It's a little harder to see here, but could be a little bit there. Try IR. Yeah, it looks like there were some clouds in the area, but not right at, it's south of San Francisco. Okay, so anything else on that before we, the next topic? Okay. So the next area is the Aviation Weather Center page, and I very quickly showed that earlier, but you can get to that from our homepage. There's an Aviation Weather Center thing on the menu, and then you can go to this page, and then from there, under forecasts, there's icing, so you can drop down to icing, and then you get the 4-panel description on the right. So you get current icing SIGMETs in the upper left, you get icing aircraft reports, so PIREPs. On the lower right is freezing level, and I believe that would be the lowest freezing level, and then forecast icing is on the lower left. So for example, we have the PIREP page. This is from a while ago. It was kind of boring, but there was one report of icing over western Montana. So we can go live to the Aviation Weather Center now. I do still have a connection, there we go. And this is what their homepage looks like when we start, so. Looks like some IFR, there must be a SIGMET. No, this is, or maybe CWA is down there. But we do have, they don't plot the VFR pilot, or the stations, they just do marginal VFR and lower, so you have the different colors across the area. They have PIREPs. But anyway, oops. So if you go up to forecasts, we'll go down to icing. Again, you can start icing SIGMETs. There's nothing out there, so. But we do have icing aircraft reports. And right now, we'll do the South Central U.S. since that's probably the more interesting. Now, there's a lot of freezing rain and everything going on in the South Central U.S. And it's probably a good thing we don't see many PIREPs because that means people are paying attention and not flying. I do have a couple icing PIREPs out in West Texas and New Mexico, but nothing like around DFW where there's definitely bad icing. And go to Southwest. See if there's more pilot reports there. So you have a couple more in the southwestern U.S. in California. And some of the clouds as you get toward the Sierra Nevada and a little bit around Las Vegas. And then for freezing level. So this is the lowest freezing level. So this is a good place where if you want just the lowest freezing level, you can get that. And so at the bottom you have the color table. So surface to 1,000 feet is in the purple, so that's basically near the surface. And then as you go blues to green, yellow, orange, red, then it goes up. And you can also, with this one, this is the current forecast. So this is 0 hour, the initialization. And then you can go out in time. You can advance it. You can see how the freezing levels change. So basically, you can see it moving. There isn't a dramatic change, it looks like, in most places, but you can see the freezing level change. You can just select different times. So go back 9 hours, and go back to the current. So it looks like it warms up a little bit in the southeastern U.S., but not a whole lot. So if there's moisture in the air around there, that's not a great place to be. And then go back. The forecast icing. So showed a little bit of this earlier and we can go into some more detail. So the main panel basically focuses on severity and also highlights areas of the supercooled liquid water droplets, and that's the red. So as you get into the darker blues, that gets the darkest blue goes into the heavy, and this is all model data forecast. And so this is the current. And you can change time, and this is the maximum level, so all the way up to 30,000 feet. You know, the max may be near the surface, it may be at 10,000 feet. It doesn't. This version does not tell you that. But if say you're planning on flying at 11,000 feet, you can go to 11,000 feet, and now this is just focusing on where you have the icing at 11,000 feet right now. So definitely in the North Texas to Missouri, Kansas area. You can also in the upper right change the forecast time. So you can see the system looks like it's progressing to the northeast. So if you're trying to fly out of, say if you were going to fly out of Dallas, you don't want to be flying to St. Louis. And you can change here you can change the different levels. So this is going down toward the surface. The grayish brown, that's just because you're below surface, so there's no forecast there. But yeah, the icing decreases a bit over the central U.S. as you get lower, but as you go back up, the threat, it goes up and it moves farther to the east. There's also, that's just severity, and if you don't want to see the supercooled liquid water drops, you can just go to severity, and that removes the red hatches. But then there's also probability. So you have just straight probability here. So this is just a probability of icing at 13,000 feet. There's no real chance. It's white, goes all the way up to orange for greater than 75% chance. And one of the things you'll notice is you go farther out in time, the chance tends to be lower. It's still updating. so this should be the 0-hour forecast, so definitely icing in North Texas. This is going out in time, so it looks like it's, again, it's the best chances for icing are shifting to the northeast. This is at 13,000 feet. And it doesn't, and I wouldn't get too excited about seeing the probability drop. It's just as you're going farther out in time, it's less certain that it's going to be icing. And we have the severity of probability greater than 50%. So you have trace, light, moderate, heavy. This isn't really showing much here. Time. There's much here. So you can see the blue. This is probability of icing at 13,000 feet. You have light or moderate. Looks like there's a chance. Basically, North Texas into Kansas, and then New Mexico toward Utah. Any questions on these? Yes.
Could you just tell a little bit about the difference between when it says forecast icing severity and forecast icing severity plus SLD, and then forecast icing probability?
Okay, so the severity, that's just forecasting what it's expecting. So expecting light, moderate, or greater, so we can go back to that.
Okay.
So we have trace, light, moderate, and heavy. So that's the forecast icing. And then if you add the SLD, that's the red hatching. That's basically where you have a chance for the super cold liquid water droplets, and that's where it's a better chance for clear icing, the very dangerous situation, so you need to be very careful if you're flying anywhere around that.
Any particular reason why on that panel, there's the SLD, but there's no moderate icing around it? I mean, it's up above it and in one area, but down below, like near Dallas, it looks, at least from this distance, that it's mostly just SLD.
Let's see. Now there's icing. It's only showing moderate at that. This is at 13,000 feet. Let's try to go closer to the surface. Yeah, okay, so now we're getting 1,000 feet. So yeah, I guess there it's not showing a lot of, I don't know if this is the water drop. So yeah, it's not showing, it's saying light, but if it's showing super cool liquid water drops,
Yeah, well,
even if it's only showing light, I'd focus on that, the super cool. Yeah, and then the other thing to remember, this is also model data, so it's not always going to be perfect. Humans haven't touched it to, make sure they agree with it. So that's where you want to watch the airplanes, SIGMETs, center weather advisories, and the actual observations, TAFs, or not TARs, and so on and so forth.
One more question?
Yes.
If I want it to be the safest and stay out of icing, which one of these would show me the greatest area of probability of icing? Would it be if I look at it says forecast icing severity plus SLD? Is that?
Yeah, and
case,
yeah, that will pretty much show you everything.
Okay.
And then if you want to focus on levels, you can, or you can just do, you go to max. So that's just the max of the entire column up to 30,000 feet. So basically, according to the model here, Washington State is pretty much fine. If you get into New England, nothing's going on there. Just a little bit as you go toward Montana.
You can also go under probability. There's a box that says less than 5%. If you go to a certain level and you say you actually want to be totally safe, then you can say, I'm not even willing to tolerate a 5% chance.
Yeah.
So that would be the way to do it.
The flight path rules can
Yes,
show.
and the flight plan tool, yeah, will be going into that, so that'll help. And one of the examples I have is just trying to maneuver around potential icing. So, anything else? Okay, so now we're going to the flight path tool. So this is unfortunate, well, I'm sorry. This is, if you go to the Aviation Weather Center page, you go up to tools, and it should be the first thing under tools, a flight path tool. I'll take you to this page, and then you just click on the launch flight path tool. Now, the unfortunate part of this is it requires Java, so not many that I know of, not many tablets. I guess a Windows 8 tablet might do it, but I don't think many others will handle Java applications. But it does have a resizable map, customizable contour intervals. And just as an example, so I will go into it live in a minute, but I'll just show you a couple panels initially. So when you first call it up, assuming you select the default, you'll get the full US, and it will show you wind speeds, and this is at, I believe, 10,000 feet. And it's contours, so color-coded, so not too strong. It looks like strongest over the Dakotas into Nebraska. And then if you go to the bottom, you can switch it to icing. So I switch it to icing severity. And then you can see icing, and again, this is archive data. So this is more icing over the north central plains, Mexico, then moving into Washington. And an example here, I did from Tuesday, I tried to do an example of a flight from Arizona into New Mexico. So, let's go back real quick. So as you can see, we do have some icing, and then the dashed area, that's an air mat in the area for icing. So I was trying to go from, so I figured go from Tucson to Albuquerque. And so as you can see, the line goes right through the edge of some, a good chance of icing. So, and then this is at 12,000 feet. So this is basically a cross section, and at the left you can see you're near Tucson, to the right you're near Albuquerque. And at 12,000 feet, it's right through a good chance of icing most of the way, and then the brown would be the terrain. So that may not be a great way, if you want to go to Albuquerque, that's going just straight path is not a really good option. But you can change the route, and I had to go from Tucson to Phoenix to Flagstaff to Albuquerque. So it's a much longer route. However, once you plug that in, you can see it going around a lot of the icing. You can see much less icing threat. So if you think you can tolerate the threat right at the beginning and right at the end, which pretty much is you're not going to be able to avoid, you can pretty much get out of the icing threat throughout the route. Just the beginning and end would be a problem. So this flight path tool can help you avoid the expected icing in that area. And just to launch it, so this is, hopefully I will be more successful than last time. So basically have to have Java installed. It should download it when you click on Launch Flight Path Tool. And once it saves it, it should generally be a pretty quick save. If you open it, there we go. That.
I don't, at home on my PC, I actually keep that download file.
Yeah.
You don't ever need to go to the website.
Right, yeah, that's another thing. You can't just save it. If you create a link on your desktop, that should work. So just loading the default setup. So here we go. As I mentioned, it starts out with the wind, and it's at 10,000 feet. So let's see, if we go, unfortunately, since it's a smaller screen, we have to try to figure out the best way to be able to see things. So I'm going to have to shrink the map a bit here. If you go to the bottom, you can turn off wind speed. Since we're focusing on icing, you can do icing, you can scroll through icing with super cool liquid water drops, or icing severity. You can try icing severity, or you can try icing. So we can do icing this time, since you had mentioned it before.
This is
So,
probability.
yeah, this is probability. And let's see, any ideas for a good path someone wants to try to fly? Let's see.
We can go through the icing, so say from Portland to Albuquerque, where you were.
Yeah, we can do that. Okay. So KPDX to KDQ. Just put a space in between. So right now, assuming you're flying at 10,000 feet, you're going to be in icing a good chunk of the way. If you think you can get up higher, you can get up to 18. Looks like not too much of a threat. But say you need to, you want to fly mostly at around 12,000 feet. So this route is not going to work, especially at the later end of the flight, the later part.
And go out to the forecast.
Yeah. Yeah. then, and again, so if you look, the lightest blue, that's 5 to 15% chance of icing. And then as you get into the greens, it's above 25%. Yellow, it's above 45%. And then as you get toward orange, it's above 65%.
Actually, the blue is an 85% chance that there's no ice.
Right, no.
I like those odds.
Okay, yeah. So you definitely want to stay in either the no color fill or, yeah, one of the blues. So, okay, and then this is one where you can change it. So you can say, so for this route, the beginning part isn't too bad. So if you start Portland, then we can probably go to, let's see, we can try to go to Las Vegas. I guess try to avoid going ridiculously out of the way. I mean, we might be able to do Las Vegas to Albuquerque. See how bad that is. Okay, so that's better along a lot of the route, but the end is still bad. It's going to be hard to avoid that, but we can if we go from, maybe go down to Tucson. Try that. So then we eliminate a lot of it. So we just have a few patches where we get in. We might even be able to go down toward El Paso if you want to really be avoiding it. And there you've avoided most of the icing. You do get a little bit, it does briefly get into the greens and one brief bit of orange. Basically near Las
If you swing around
Vegas.
Sacramento,
Yeah, if you
you'll
go,
avoid that.
yeah, and then you can do Sacramento, that should take care of it. Of course, some of these may get so far out of the way, you have to be careful that you'll be able to get enough fuel in your plane. So at 12,000 feet, the only issue here is you'll have to go up at some point a little bit when you're getting over the Sierra Nevada. But yeah, this is a great tool to be able to do that. And if you want to switch it from just icing potential, you just do icing severity and switch that, see what it looks like. So chances of a little bit of light icing, a couple points before, when you're going into California, and then not much until the very end. And again, if you're going to Albuquerque, there's not a lot you can do at the very end. You're just, you might be able to get
a good graphic of the effect of lifting on the west end of the west side of the mountains?
Yes. Most likely have some lifting because the winds are coming from the Pacific, so you're getting the lift. And lifting is one of the factors that helps to condense the moisture. So if you just have some moisture in the air, but it's not visible, and as you lift it, there's a better chance it will condense, and then you can get clouds, or you can get ice, or you can get precipitation falling, potential for ice. And there are also, so you can also put up temperature, so you can see the temperature curve. So the blues are all below zero. The kind of beige into the red, that's all above zero. So as long along your flight path here, you can see you're basically below zero most of the way. You can get farther up. So as I mentioned, as you get closer to negative 40 degrees Celsius, assuming you have a plane that can get high enough, you're much less likely to see icing. So one of the potentials is to go farther up. So if you can get to 18,000 feet, some of the icing that was occurring in Oregon to California probably isn't an issue now because you're starting to get into the darker blues. You're getting, it looks like negative 25 or lower. So we can go back to the icing probability. As you can see on the map, there's nothing now at that height through Oregon and California, and in this you can see it's all below. And the other thing on this, there are other things you can plot on here. You can put wind barbs, and that's at the flight level. So as Jim mentioned, you do get a little bit of wind. Looks like it was coming. Yeah, it looks like it was coming off the coast earlier, but then it's right here. It's just coming out of the north. So when it comes out of the north, it was still getting uplift going into the mountains, that area. And you can have airports. overlaid, which is kind of busy. You got VORs. You can hover over, you can see the different VORs.
What's the VOR?
It's a wakeboard.
Oh, wait.
Yes. So, and you can put at our location, this is probably going to take a sec since we have a lot, but you can hover over and get the different observations. Try to zoom in first. And just see, you can hover over and you get the observations. So ceiling 800 feet, visibility 2.5 miles, you can hover over the different terminals. So this is a great interactive tool, and I do hope at some point they switch it over to HTML5 so it'll be universal, you won't have to worry what you're using. But for the time being, it's still in Java. Oops. So any,
We're gonna go out to the different forecast periods and see how it changes?
yeah, we can do that. Load that again. But make sure everything fits. Okay, so direct route, and this is, right now it's on wind speed. If we do go back to, this is icing potential. Get this over. Okay, so if this is icing potential, and this right now it's showing at, looks like it's, basically we're at 19Z, so we can slide this over, and go over to 2230Z, so it does do a forecast. So you can see the icing potential. And again, as you go out in time, the icing probability may drop some, and it's not necessarily because it's less chance, it's just the forecast is farther out, so the confidence level will be a little lower. But we do still have icing as you get out to 2230Z, and you can go out to 0Z. You still see there's still going to be icing through that area. That's pretty likely. I mean, you're still above 35% across a lot of it. But if you switch the route again, go back to KPDX, KS, something like that. So trying to go around it, assuming you get up to, say, 15, at least try it right up to the 15, 16,000 feet, and then you can avoid a lot of the icing. Oops. That's not what I wanted.
As well as the terrain?
Yes. Sometimes
Is that important?
Occasionally.
You can do it once.
Keep clicking the wrong thing.
Make the front page of the paper.
15 minutes of fame.
Yeah.
There we go. Now we'll try to do it again. So, okay, so you're avoiding the terrain, you're avoiding the icing as you get toward 15, 16,000 feet. And this is the forecast, so this is farther out. And bring it back to closer to current time, still avoiding it, mostly above the icing area at this point when you get up to 16,000 feet. Looking at the severity, again, it's close to when you potentially would be taking off. It looks like you'll just skim the tops of it. It looks like it's about 15,000 feet for the worst of it as you get toward the Sierra Nevada, and then at the end of the flight. And as I mentioned before, you can also check out the temperature. So you're definitely above freezing, or I mean above the freezing level throughout the flight until the beginning and end of the flight. And there's also, I didn't show this earlier, but you can look at the relative humidity. So another good idea to see if you're going to have icing. The relative humidity is low, so that's when you get to the orange and red. Not really going to have to worry about icing in that area, but when you get to the greens, that's where you have much more moisture available, so a better chance for icing. So definitely the lower elevations, close to the mountains here, have a better chance for icing, assuming the temperature profile is right. Anything else? Try another route, or just go on to questions?
This is
Anything?
this is an incredibly good tool. I mean, you can, it's got a lot of flexibility to it, and you can look at different things, but mostly about being able to, carve out a route. If you still need to go, carve out a route around the icing.
Yeah,
At least the potential for icing.
Yeah, there's only so much you can do at the beginning and end, but if you can avoid it through like 95% of the flight, that might make it okay for you to be able to fly.
Good, okay. All right, I thought maybe we could have a few minutes to chat a little bit about stories. Anybody have any stories about icing that we can chat about? Hang on a second, Nick. Anything that, you know, you'd like to share that would be about, you know, stories? We did a little bit of that last time, Bob. You had some nice stories about what, well, maybe not so nice, but some interesting stories. Nick, you have one?
If I may, I have a few remarks about flying airplanes in icing conditions.
Okay.
Sure. So, thank you very much. Appreciate the presentation. Of course. And the cookies are awesome.
Are there any left?
Probably not.
Couple.
Ooh.
Better
So,
run.
by virtue of a job that I had a while back, I learned some things about flying airplanes in icing conditions.
What were those jobs?
I worked at the beach factory. I was a beach factory instructor for about 12 years. So I worked for Flight Safety International for about 10 years because they were the company that contracted for beach to do the factory instruction. So I was a factory instructor, and then, as they say, they sold the slaves with the plantation, and I became a flight safety instructor. And there were some things that came out of the learning I had in that job that are instructive to me in terms of how I think about flying in icing conditions. And some things that were said here. One is, I distinguish between FEAKY and non-FEAKY airplanes, FEAKY being flight into known icing conditions, and airplanes that are equipped for that. Mostly I fly non-FEAKY airplanes, and they seem to be the ones where I get the ice. There's a rule about that, I guess. I don't, if I find myself encountering ice and it's in conditions where theoretically I could climb above the icing conditions, I don't attempt that. So you could get the impression, you know, gee, I flew into an area of super cold water, but I know there's warmer air above and I can climb to that warmer air. And one of the things pilots often do not appreciate in light airplanes is the rate at which the climb performance diminishes as ice accumulates on the airframe and especially on the propeller. So the notion that you can enter a climb and climb out of ice that's accumulating on the airplane, and especially on a light single engine airplane, scares the heck out of me for several reasons. One is that the ice sometimes comes off portions of the airframe, especially the propeller, and if a single blade sheds its ice and the other two blades still have ice on them, it will shake the shit out of the airplane and out of the pilot.
Is that a technical term?
It's an extremely uncomfortable situation.
Shake the ice off.
So, maybe. But the airplane doesn't climb very fast and may not climb at all. In FEAKY airplanes, there's often a published airspeed, which is the minimum airspeed for flight in icing conditions. And the reason that airspeed is published is, for the most part in the beach products, the ice protection on the wings was inflatable rubber boots. And what was discovered is that pilots would fly into icing conditions and get the notion that they could climb out of the icing conditions, so they'd pitch the nose up and get the airspeed low, at which point the ice would begin to accumulate out of the pilot's line of vision underneath the wing, where it was not apparent that the ice was accumulating. And for that reason, then, the boots were not effective, and the ice was accumulating. Obviously, the same thing can happen in a non-FEAKY airplane. If you succumb to the temptation to think, I'm going to climb out of this, you haul back on the yoke, you might look out and say, hey, I'm not getting any ice right now, things are going well. And that may not be the case. So my general recommendation is, if ice starts accumulating on the airframe, there's one thing that you know, and that is before you were accumulating ice, you were not accumulating ice. And if you want to climb above the level where ice is likely to form on the airplane, A good way to do it is to go someplace where the airplane's not accumulating ice, continue the climb, and then proceed on the route. So one of the things that you said, and forgive me for this because I'm going to contradict something I said, and you may want to change your slide, and that's light airplanes don't climb above 8,000 feet. In most cases, particularly in cold weather conditions, that's not true. You can climb well above 8,000 feet, particularly if you continue to lean the mixture for rich best power. You can probably go up to 15,000, 16,000 feet in a naturally aspirated airplane. For that reason, one of the best pieces of safety gear you can get for avoiding icing conditions is actually an oxygen bottle. So you can get a Skyox or a mountain high oxygen system with cannulas. You can use them up to 18,000 feet. And if you can climb out up above the clouds and avoid the clouds entirely, that's a whole lot better. So with regard to Fiki airplanes, who flies a Fiki airplane? Okay, how's your airplane protected? Is it boots, hot prop, heated windshield?
There's 2 Malibus out there.
I'm sorry?
Those 2 Malibus out there, that's what they fly.
Okay. So, Fiki airplanes are in theory, you can fly them in icing conditions. I once had a chief pilot for a very large corporation ask me if I should fire one of his pilots. And the reason for that is because this pilot flew an airplane, in this case a Beech Model 58, into icing conditions. The airplane was a Fiki airplane, so the question was that poor judgment? Well, what happened was that the airplane had heated boots on the propeller blades. And there were 6 heated boots, and 5 of those heated boots were functioning, and 1 was not. And so ice accumulated on the propeller blade of the unheated boot, and it shook the heck out of the airplane and scared the heck out of the passengers. And so the question was, did he exercise sufficiently poor judgment in doing that he should be fired? And the situation with that particular airplane is that the boots cycle in 90-second intervals. So the right prop will heat for 90 seconds, and then the left prop will heat for 90 seconds. And if you turn the switch on for prop heat, and you look at the ammeter, you're supposed to look at the ammeter and see that it indicates full amperage that shows that all the boots are heating. And in this particular case, he didn't wait 90 seconds to see if both props were heating, and so he missed that particular aspect, which is pretty easy to miss. So I didn't make a recommendation. I just said, it's understandable how a pilot could miss something like that. We had a situation where King Air was making an approach to landing and had a little bit of ice. In fact, the pilots looked out and said, there's no need to cycle the boots because it's only a little bit of ice. And that airplane hammered onto the runway really hard and it was damaged. And in the ensuing investigation, and this is applicable to all of us, they made a determination that the determination was that the airplane had stalled prematurely. So the accumulation of ice, if you look at, you watch the slides with the ice accumulation, and you look at some airplanes, a Bonanza is a good example. If you look at the inboard leading edge of a Bonanza, it's got a little wedge. And that little wedge, it's usually a few inches long, is a stall strip. And the purpose of that stall strip is to stall the inward section of the wing so that you get aerodynamic buffet before the outboard section of the wing stalls, so that you have aileron control as the airplane's flying into the stall. So what happened with this King Air 200 is that there was just a little bit of ice, but the accumulation was in that wedge shape of a stall strip. And so what happened is the airplane literally fell out of the sky without warning because it had full span-wise stall strips. So that's item A, and that's something to think about if you have just a little bit of ice on the leading edge and it's rime ice and it's in that shape. The second thing, and you talked about this, is that ice accumulates on thinner surfaces more readily than on fatter surfaces. So big fat round wing like on a Piper Aztec, won't pick up ice as readily as the tailplane. How many of you are familiar with tailplane icing? I've heard about it, discussed it. Okay, so there's a few who have not. Under some circumstances, it's possible for the tailplane to pick up that little wedge of ice, and the wings will be clean. You might see ice accumulation on the OAT probe, but there's none on the wings, and you think, hey, I'm good. There's no ice on the wings, but there is ice on the tailplane. And that ice on the tailplane, if it's in the right shape, will dramatically increase the stall speed of the tailplane. And we don't think about that much. But this has been implicated in a number of accidents where what happened was there was ice on the tailplane, the airplane was making an approach, the pilot extended full flaps. And with the full flap extension came an increase in the stall speed on the tailplane. And so what happened is the airplane abruptly pitched nose down and was unrecoverable. So at flight safety, they make a big point about talking about tailplane icing. If you have a Fiki airplane and you have boots, the recommendation is you cycle the boots if you're making an approach to landing if you have any reason to suspect that there might be ice on the airplane. If you have a non-Fiki airplane and you have reason to suspect that you have ice, or you have ice on the wings or you have ice on the tail, the recommendation is that you not use full flaps ever. And you may want to use no flaps depending on the tendency of your airplane with flap extension. So, but full flaps are a no-no. Pick a longer runway, come in a little faster, and avoid those situations. So those are things that I think about when I think about flying an airplane with ice on it. So I wanted to say that. Thank you for the time. I appreciate it.
That's good.
So I've been reading more about this stealth organization. I think somebody moved up from Southern California, this ice thing. And one of the things I read was that, and so I'm asking a question, I'm not sure what I read, I understood. The FAA is rethinking the certification for flight into known icing because they don't think the standards address roll stalls, because that's where you've got a thinnest section of your wing, and if you get clear ice, you're gonna build up some ridges behind the boots that are gonna make your ailerons ineffective, and one of them can stall.
Right, so that was the
Did I understand that
Rose
correctly?
crash,
Yeah.
and it was super cooled water, and it accumulated ahead of the ailerons, and the airplane became uncontrollable and rolled. And yes, they are rethinking the icing certification standards. So there's several levels of icing certification. There's CAR3, and if you have a CAR3 airplane, you might have a statement in your pilot's operating handbook that says flight in light to moderate icing conditions is okay, provided you have this equipment, which is typically boots, some kind of prop protection, some kind of windshield protection, pitot heat, and fuel vent heat. And if the airplane's equipped with that, then you can fly in light to moderate icing conditions. They later updated that to FAR 23 known icing certification, which is actually Fiki. And if your airplane is Fiki, then you can fly into icing conditions, recognizing that there are some icing conditions that will overwhelm even a Fiki airplane. And the only thing you can do is avoid.
That was the inference I drew from reading that is, gee, I may be in an airplane that I think is certified for Fiki, but the FAA is now saying, I wonder what Fiki really means now. And so you're going out there thinking you're okay, and you are not.
Well, in the Roselawn crash, what was happening is the airplane was orbiting, and the autopilot was on, and it was collecting ice, and the pilots were not aware of that. High wing turboprop. The ice protection equipment was on and ostensibly working. So, you know, it's entirely possible, even in a Fiki airplane, to get overwhelmed with ice. There are no advantages to flying in ice that I can find. And the thing about Fiki airplanes is all that stuff has to work. And a lot of times people are not diligent about checking things like fuel vent heat. Most people check the pitot heat, I gave you an example of a pilot who had prop heat but was unaware that one of the prop elements was not heating. And sometimes you get a situation where one of the boots does not inflate on a boot-protected airplane. It's nice to know that before you take off, but a lot of pilots don't check their boots before they go flying. So they find out when they've actually accumulated ice, which is a really bad time to find out that one of the boots doesn't work. So icing is really hazardous, and it scares the heck out of me. I really don't like it at all. Most of the times I've gotten it in non-Fiki airplanes, I've ended up praying, and I hate praying in airplanes. It's one of my least favorite.
Well, thank you, Jim. That was very nice. Appreciate that. And hey, we'll get some questions in here in a second. But, you know, so this is sort of the official end of this thing. And as I say, I've got a DVD on icing that I will play after we break up here. But Jim's going to stay around for a few minutes if you want to go through some of those websites that he went through, and you know, make sure that you've got the website addresses are now on that link that I gave you. So if you went to the link and downloaded it, it didn't have this slide on it, so just go back to that same link, and this slide is now on it. And then you can you know, play around with it.
What link are you talking about?
Well, any of these links.
No, but I mean
Your email?
Oh, the link that I sent out in the email with the slide presentation on it?
Oh, okay.
Yeah, that was the one that Jim
No, I got it.
gave me that I forwarded everybody. If anybody didn't get it and wants to see it, just send me an email and I'll send it to you again.
And actually, if you go to our website, when I get to work later today, I'll put this on the website. The last one I put up a couple days ago, so this one will be, if you go under the training section on our website, this will be there. So you don't need to find that obscure link, you can find it directly, there'll be a link. And we have other presentations you can look at there too.
And Rick, you had a question?
Yeah, I'm just trying to think of how to think about this simply for the majority of us in this room that have carbureted engines, non-Fiki airplanes, and I think the first thing I think about is I'm not even leaving if there's any ice in that forecast. So that takes care of that problem. I'm no longer dithering on the issue of which route to take. You know, I'm just not going anywhere, so that's number one. But if I did get into a problem in a 182 with a carb that has known problems with ice, okay, would the simple response be to do a 180 and descend as best I can, given the terrain that's around me? Is that simple rule the best rule?
Yes.
Because you said you can't climb. Like, I don't have time to pull the iPad out to see where the ice is and isn't. So 180 and descent.
Well, right, so the one thing that you know before you got ice was that wherever you were flying, you weren't getting ice.
Which is why I'm following up with that question, which is a
Right,
good thought, right?
so as soon as you start getting ice, the question is, what am I gonna do?
Right.
Well, if you wanna buy some time to think about it, which is a really good idea, the first thing is a 180, put yourself in a situation where you are not accumulating ice.
Right.
At which point you have all of the time your fuel will permit to consider what your options might be. Now, if where you're not accumulating ice could be in the clear, right? Especially if you're crossing the Cascades, right? You might have a situation where you can fly a few miles and you're in clear weather.
But you don't know
At which
that,
point you might be able to climb, get over the conditions.
Yeah.
Do you have a carburetor air temperature gauge?
Yeah. Yeah. But the problem is that's not the simple scenario, because it's a bet as to what's ahead and
Right.
what's above.
Right.
It's not a bet on what's behind you and what's below, assuming you just take advantage of the lapse rate, right? It's 2 degrees per 1,000 feet. Let's go down.
It's the standard lapse rate, so it's never standard.
Well, of the bad options I have, this is my question, I'm trying to get, I'm trying to make it a simple question so I get a simple answer. Of the options that I have, and I'm in a stress situation, in a situation I don't want to be in,
Right.
and I want one rule, and only one rule.
Okay, one rule would be immediately turn the airplane into conditions where ice is not forming.
which is a
That-
180.
So is
180.
is that the 180 answer?
Well, that's the 180 answer. So in your flight planning, I guess my question would be, you want to fly from here to Portland, right? So you look and it's cold and there's going to be ice at certain altitudes. And the question is your altitude a freezing altitude? Are you at or below freezing at the altitude that you select? And the next question is that the minimum altitude that you can make the route? Right? So if you can make the route at 4,000 feet GPS direct and ice is at 6,000, your airplane performs better at 6,000, so you say, well, okay, it's freezing at 6,000. I'll try 6,000, but if I get ice, I can go down to 4,000 because I know it's 4 degrees warmer there. Then you have an out. It's really simple. You file for 6, but you know that you could go to 4, and you have an out. If it's freezing at 4 and below you is terrain, and you planned your flight in visible moisture in freezing conditions with your minimum en route altitude, in freezing conditions with visible moisture, you made a flight planning mistake.
Yeah, I guess I didn't plan to be in the situation. I wouldn't have left if that situation was there. So we're in a situation that wasn't planned, wasn't anticipated. Could have been a forecast where his models aren't accurate. Okay, so let's call it an unforeseeable situation. But I think you've answered my question, which is all things being equal, if you've got terrain below you and you had no ice behind you, it seems like we should just turn around and.
I was in kind of a similar situation last year, flying to Grand Coulee Dam on, it was Victor 2 IFR, and I was at 13,000 feet. I left here, tops of the clouds were 8,000, but wind lifting. I started getting into the clouds right before I got over the Cascades. And so I asked for 14,000, I got it, but I was only a few hundred feet above the clouds. But with the rules, you had 30 minutes between 12.5 and 14. I was wondering, like, if I got another 1,000 feet of clouds, would it be better to climb to 15, stay clear, and then, you know, luckily I didn't have to. I stayed at 14 and then was able to get lower in eastern Washington. Whereas, you know, it was severe clear after you got past the Cascades. But you know, I will look into getting an oxygen bottle.
An oxygen bottle is a really good idea because ice accumulation is bad, but hypoxia is also really bad.
Right. So it's either one or the other.
So
From a planning standpoint, Rick, as far as I'm concerned, you know, that's why I really like that flight path tool, is I'll look at it, if there's a 55% or less chance, I figure my odds are pretty good, and I'll go up and take a look. If it's 55% or more, I won't even go take a look. I don't care whether I'm TKS equipped or not. You know, the ice is ice. You know, that TKS system is a get out of jail free card. It is not a go and slog around card. But the 55% is really a nice kind of cutoff. You know, my odds are good, and so frequently I've gone up and there's no ice and no problem, even though I'm below 0 and invisible moisture. But I know I can go back. But I'll go up and take a look. But if it's 55% or greater, I won't even go take a look.
Because, you know, the way I look at it, we have professional pilots crashing because of this conversation. And I'm not a professional pilot. So my chances of doing better than them are like 0. Right?
But don't forget, they're under the pressure of getting to the place because they're getting paid to get there. And, you know, the old saw about if you're too chicken, you'll never fly. If you're not chicken enough, you'll never fly again. So they have a lot of pressure. They don't have the option of saying, well, no, I'll go another day. So they get into situations that they, even their own judgment would say that that's not a good idea, but they're pressured to do it.
I've got a question about that.
So declaring an emergency, if you're, excuse me, I interrupted you, I'm sorry. Please go ahead.
Well, I just had a question about this turning 180 degrees to get out of the ice. Say you're flying along, it's below freezing, and you do the stupid thing of going into a cloud, you pick up ice. You turn around, you come back out, you're still below freezing. How long does it take for that ice to go away?
If it's below freezing, it may take quite a long time. And now the ice will sublimate off. but it's not gonna happen real quickly. It only happens quickly if you get into warmer air.
Okay.
Now, it has to be above freezing temperatures, and then it'll come off pretty fast.
Or sun, if you're above the
Sun
clouds.
will, you bet, absolutely.
Okay.
So it'll sublimate off if you get good sunshine. Otherwise, it takes a while.
10 minutes?
So most people do not think of declaring an emergency if they start getting ice on the airplane. But if you're in a non-Fiki airplane and you're accumulating ice, it is an emergency, and it's something that really demands immediate action of you. So it's one of these things. You can listen to people hang and talk about how much ice a 182 will carry. And depending on the kinds of ice, a 182 is better than some airplanes as far as being able to fly with ice on it. The rub with that is that ice comes in so many different configurations, and as it accumulates, it changes the shape of the airfoil, and you become a test pilot. And the biggest risk from that is the stall speed of the airplane. So if you do happen to accumulate ice on the airplane, probably the best thing that you can do is fly to warmer temperatures. But if no warmer temperatures are available and you want to land, don't extend the flaps. Keep the speed up. Find a long runway so that you don't have a premature stall as you're making the approach.
We're going to talk about declaring an emergency.
People hate declaring emergencies. I hate declaring emergencies. And so they're reluctant to do it. So if you find yourself in a situation where you're picking up ice, ATC doesn't know that, you got to tell them, hey, I'm getting ice. And they say, okay, what are your intentions? And you say, well, I want to make a 180 or I need to descend 2,000 feet. And they say, I'm unable to do that for you. Then you can say, well, I'm going to do it anyway. I hereby declare an emergency by virtue of the fact that I'm accumulating ice and I'm going to make a 2,000-foot descent. And then let them worry about clearing out the traffic below you or behind you or whatever it is. Because you are entering the realm of test piloting. And it's not an emergency right up until it becomes an emergency when you lose control of the airplane. And that's what happened with, like the Roselawn crash and some of these other crashes where everything seemed to be going more or less okay right up until the point where the airplane became uncontrollable. And then it crashed. So the problem as a pilot is you have no idea where that point is.
I was just thinking of something. In some of your teachings, could we assume that if the air is stable, that the 180 and the descent is a good idea, but if it's not stable, that might not be a good idea because you have lifting action?
Yeah, I mean, if in just a very brief amount of time, the icing pattern may not change, but if it takes you a certain amount of time to turn around and you're in a convective environment where it's unstable, you could have a thunderstorm developing. 15 minutes could be going from a clear sky to a queue developing. So you could go from potentially no icing to icing, but that's in an unstable environment. Stable, most likely if you didn't have icing before, it probably hasn't changed in 15 minutes.
Great, thanks for all coming. One of the things I'd like to do is,